Hi, I'm Warren Jones. If you're watching this, you're through episodes 2, 4, and that means you're over halfway done. Woohoo! So keep watching. It's all downhill from here. And thanks again for watching the Intelligent Computer Podcast. And please join us at wjones.com if you have any questions, because we've got lots of illustrations there. And also a nice tab at the bottom. Click where you can just contact us if you have any questions that you can't answer by reading the site. Thanks.
This shows another view of identity, and here from the perspective of curtailment, which is something we had to work on as a method to ensure levels of control within an intelligent system, even though it may have this free will or read-write ability to define its own identity to an extent. So there's a lot of, it's probably some of our most complex science, the science of curtailment. How you can ensure that certain thoughts like protection of client or insurance of safety, following of legal rules that apply to your client, how those would be processed in advance of other requests in a service entity. Sort of a transportation bot, how to make sure that bot, when it's going from Maryland to New York, will stop and desist and submit itself to police inspection, but at the same time won't allow itself to receive different purpose from those that aren't authorized. So there's a lot of complex science that we've done some work on there, and certainly over the next few years, that's something that's going to require the most testing. Here we'll talk a bit about agents, the specific different agent templates as we define them. On the website, we have a nice page that lists all of the known agent templates that at least we've done design on. Third-party companies will define, there'll be thousands of agent templates over time, maybe as many agent templates as there are versions of fruit flies, you never know. But what we've done is we've focused on a couple particular types of agents. One of those is the assistant agent, which is an entity that would work between your mobile and your office, your home systems, and essentially cater to your needs. Its job is to understand the symbols that are in your life, your responsibilities, your resources, and then to process those as if it was thinking them as its own mind. So for example, it could predict what you might need for the day. It could predict your requirements for resources, whether it be at home and in the office, and facilitate those such that when you need, let's say, the projector to have a document on it, or you need for food to be in an oven, the agent can take care of that for you. Common sense, that's something it's a specific type of purpose that's developed to be loaded in an agent when an agent template is placed in a very specific situation. So for example, let's say an agent template was to be loaded in an oil rig offshore because it's going to be directing a set of bots that's going to be cleaning up an oil spill. So that agent would have to know the language of the various different entities that are out in that environment, would have to understand the specifics of oil, or the specifics of the company that might be running that, the languages that it knows. So common sense purpose essentially is a breakdown of forms that relate to the specifics of trade, community, or family if it's a home-based agent, and enables that agent to understand and to fit in with an environment. So that allows one company to define or to develop a very good set of lawn maintenance bots, but not necessarily know the specific needs that, let's say, a hospital might have as far as maintaining its grounds versus a suburban home. Another thing we'll talk about are applications of the technology. Here we're looking at a breakdown of the various different symbols that are in a home environment, and the other type of agent that we talked about, the assistant agent. The other major type of agent that we'll talk about is the Nexus agent. It's a Nexus class, and that the job of the Nexus class, rather than specifically assisting a person, the Nexus class agent will assist a metacomputer. It'll be the senior most agent in a metacomputer. And since metacomputers are actually homes for multiple agents, There could be, let's say for you, when you go into the office, your agent is now roaming to the metacomputer of your office. There'd be office metacomputers that might be maintaining documents or maintaining the grounds or maintaining the lighting systems or the heating systems. So all of those agents themselves must exist within the metacomputer environment. And the Nexus agent is sort of the top cop, the sheriff, that watches all the agents, make sure they comply with patron rules. Patron is the owner of an intelligent system, and complies with other rules. And when agents need to be upgraded, it'll facilitate the sleep and wake process for that, and it'll all the other things that need to happen within a multi-agent environment. So that's the job of a Nexus agent. Here we're talking about just giving an example of a very specific type of Nexus agent, one that's optimized for the home environment. So let's say you went to the store, you spent $9.99 on your redundant home-based metacomputer and adapters for your OMAP-based handheld communicators. And OMAP is just the processor technology that's in every Android or iPhone or pretty much most complicated telephones today. So that Nexus agent would then coordinate the information for your home and control of any of the devices in the home, and pretty much assist you in the ways needed. One of the particular differences we had to work on with regards to an agent-based environment is the concept of user interfaces. And it's not that the user interface goes away, but now the user interface has two parties. There's the agent, which is looking at working on your information, understanding that you have a report due tomorrow on this topic, and maybe organizing that information for you. And then there's you, who is used to doing everything because computers are pretty dumb as they exist today. So in the new environment, there's this teamwork where the agent, knowing that you have this report done because it may have been in the room with you as you were assigned the report, it's already started gathering the information for you. And here what we did is we prototyped using, and everything is designed for either the web environment or you'll see some smaller mobile prototypes, but where it's actually presenting the information to you in a magazine format so that you have the various different categories of information. And you can browse through that and then also have your collaborative information mail related to it coming in. So these are agent created on the fly user interfaces, which is quite a bit different than the hard-coded user interfaces that you typically see on today's Windows and Macintosh systems. Just another example here in a smaller form factor. We thought we could do circular. We tried. I think this is one that I wish I could build today, because if you looked at our square ugly black prototype that has a WebKit browser, it's nothing compared to what we're able to render using the graphics tools. But the basic way it works is you stick your thumb in the middle, you move it towards the various different conceptual icons. The agent interplays with you, and because you're in context, you're in a locale that might be a room. When you go to the file, it knows that you're talking about, let's say if you're in a hospital room, it knows you're talking about probably the patient file if you go to the file. And it knows if you're moving to the display, you're probably talking about the HD display on the wall. So the agent interacts with you as you're working your way through the user interface. Again, these are prototypes that we've done. These all can work on the basic WebKit interfaces that are on the OMAP devices. But like I said, there's a few years work to be done to get this stuff working right.